Alright, DraftScience video. So I'll respond to the comments. Thank you to those who participate. And just say in general, I don't think you're counter-arguing with anything that disputes my theory that the sound is produced by a movement that exceeds the speed of sound. So that all sound that we hear is the byproduct of sonic booms, very small ones. Yeah, so I'll read the comments and just point out that I don't think that's been disputed by anything. You haven't demonstrated to me a sound. I guess that's the thing to do, is to show me a sound generated by a source where I can't argue that the source is moving faster than the speed of sound. Yeah. So anyway, yeah, and so I was thinking of a way of describing it as you know, this thing that's happening between the atoms is migrating something, right? So something happens. There's one sitting here, and it has a neighbor, and somehow it's transferring what's happening to it over here. It's transferring it to this neighbor, and it's doing it though at this fairly slow rate of speed. I mean, it's not like if they were solidly connected. You can almost imagine how it would be instantaneous, that you push one, like if a bunch of billiard balls were connected end to end, you hit one and the one at the end pops out, and it seems almost like it should be instantaneous. So there is obviously a time it takes for that transmission of movement to be conveyed, but you have the feeling like it should be, like what should stop it except for some kind of compression. Something has to be compressed and then it has to expand again. Some sort of elasticity has to be in everything for there to be any delay. So for there to be a delay, there has to be elasticity. So theoretically, if this object was solid steel and I could go all the way to the moon with it and I could push the moon, there's a sense that I should be able to push the moon instantaneously, faster than even light could move. Just by tapping one end, I should be able to tap the moon. But we don't have any materials that can do that. But all the materials that we in the known universe are going to compress under the extreme forces of that distance, you know, multiplied by all the little elasticities of all their atoms. Anyway, I want to get into something too complicated here. So the point is that sound is very slow for a vibration. You tend to think it should go much faster through something, and it's always through something. As again, this argument is you know, we get this feeling like normalcy is being in this substance, but we're really swimming in a substance. We're not in a vacuum. We're not in a clean atomic area, and sound doesn't travel through a vacuum. It doesn't travel through an uncompressed world, and the compression is what's creating the tension, and the compression is the obliging of atoms to be perhaps closer to each other than they would like, or at least close to each other in association. So I was thinking about that whole idea of when they bang into each other, so I'll just throw this in since I'm thinking about things. And I was thinking about heat and infrared light, and I was thinking about in terms of that the light is likely something being, you know, it's like you could almost think of burlap, you know, some kind of fuzzy fabric, and as the atoms hit each other, pieces of the burlap fly off, and so the more interactions the atoms have with each other, the more they rub up against each other, the more little fibers of burlap fly off. And it's kind of like that with heat and the byproduct of infrared light. And so this light, you know, might be part of the electrons on the outside of atoms, and they just, there's an association between the atoms, and that something's binding, and as if, and when they are forced to vibrate at certain frequencies, it breaks the binds, it breaks the fibers, and you get these little, you know, shards of photons that fly off of them. Something like that. And then they reattach to another atom, or they go off into space, and if they go off into space, obviously if it's a closed system, things would slow down. So there has to be some other source of them. You have to keep producing more fibers into the system to maintain it, some sort of something that would create something that fibers can be made out of, more atoms, more interaction, something like that anyway. It gets a little bit tricky just trying to think of the efficiencies of it. But see, the tricky part is that you can't, it's really hard to imagine things in a vacuum because they're just so used to living in a world that's not a vacuum. So it's not intuitive. So anyway, in thinking about these associations of these atoms and how they are transmitting a sound wave, how they're propagating something, I was thinking of magnets. And if you push two magnets together slowly, one magnet moves out of the other magnet's way, and then as you remove it, it'll go back to its regular position. So if you had a magnet on a string and you pushed another magnet towards it, it would move out of the way and then go back again. But if you did it quickly enough, okay, if you do it fast enough, you'll hit the other magnet. You'll go faster than the speed of the force that would shoot the other magnet off. So if you go quickly enough, you'll have a kinetic impact, a real impact with the, say, the center of gravity of the magnet. Or so if you were talking about atoms, you can just imagine that they would have a nucleus and a core and a field, and that if you go into the field slowly, you just kind of push against the field. Yeah, the field will push the atom over, and then it'll expand back, and there won't be very exciting. But if you push it quickly, if you jab into it, then you hit something through the core. It's like you get through the membrane, and you hit the center of gravity. You hit the core, the hard part. And if you hit the hard part, then the vibration will be much quicker. And so I think something like that's happening with the sound, the speed of sound, is more about the speed of transmission from core to core, rather than from just moving atoms as if heat or something were generating more speed or more interactions. So I think that's probably enough. But yeah, so I'm just still dealing with the same words: tension, rebound, center of gravity. I think it's an interesting concept for atoms themselves. I call it a core hit. But even the heat and the infrared thing is a sort of interesting thing to think through. And for a while I did, when I was younger, I did work with transducers, for ultrasonic sound. And it's kind of funny because back then I was using it roughly for imaging, but in a very crude way, just looking for holes in materials. And I'd actually thought, this is before the ultrasound days, before they had ultrasound, and I actually thought about, why not use this as an imaging device? I mean, so I'm not saying I invented it, but I could have invented it, damn it. And because I just realized that you're using a much higher frequency, and in terms of the sound waves you're generating, and they're much cleaner, so you can actually resolve images of things in a crude way. You can make I made detectors where you could detect things 10 feet away as things, and it had all kinds of I guess they did make something for the blind, where it makes sound based on where they point their head. But yeah, I was crudely doing that 30 years ago, and if I had any brains and stuff, I would have capitalized on that, damn it. But anyway, that's a whole nother, the zillion things I never capitalized on. But anyway, just totally just ignore that part. It's just unnecessary distraction. Alright, so I just get to it. I mean, I did do some thinking about this idea of photons being two things, the two quanta, and that they tumble. And I kind of ended up with, I'm thinking of like a DNA molecule, a double helix to describe the spin of electrons, and I'm kind of thinking now of RNA to kind of describe the function of a photon, in that it's a, to get to the polarization issue, you have to get to the shape thing. Photons have a shape, and I think to create the shape, I think you can do that through a tumble of, a barbell, essentially. It's just two ends, and they tumble to create the, their movement through time. So it's like literally a domino falling in a direction, and the fact that it falls in that direction means that it would have a shape, horizontal or vertical in terms of its length, tumbling whichever way it was tumbling, and that would give it a shape that would be filterable through polarization, and that sort of would explain polarization. So I'm liking that because it also explains frequency as being a component built into the photon, so that the photon has an actual frequency, which is the distance between its initial quanta and its second quanta. So this distance would be its frequency. But it kind of kills the sine wave crap and gets you more to a just peaks that the tumble would be creating. But that's, I have to do the math on that one and a lot of other stuff. But anyway, I like the idea of it because it does, it gives frequency something more coherent to, I think, a more mechanical function. And so I'll see where I can go with that. But anyway, it all gets, poof. Anyway, but I think this is the way to go. I mean, there's a model here somewhere. Physics, there's a model. There's parts that make the universe work, and somebody should be doing this stuff and figuring out these different ways it could be configured that have something to do with something, I think, more simple instead of these complex things that people come up with. They come up with these abstractions and flowy stuff and plasmas and all kinds of other nonsense that doesn't have any. It doesn't have any mechanical. It doesn't get to anything simpler. It doesn't get to the checkerboard. And there's a checkerboard underlying all this stuff. So anyway, comments. Alright, Mr. Roboto2, who, I find to be an irritating sort most of the time, in terms of his comments. He's big on this quantum physics crap and all that stuff. So anyway, and this comment, I just didn't see anything, there wasn't any detail to it. Alright, waves propagating through solids do involve tension. Well, see, I'm going to argue that anytime two atoms are connected or associated with each other, they're tied to each other in some way, and some might be subtle, like Velcro. They're tied by like a Velcro. They're not making a chemical bond. They're just associated electrostatically, you could almost argue. They have an electrical connection, and it's very weak, but it's there. Like magnetism. Since the atoms in the solids are held in place by restoring forces. Pressure waves through gases, however, are propagated by a somewhat different mechanism. Well, I'm going to argue it's all the same mechanism. The only thing different about gases is that the atoms are, in a way, bigger, airier, fluffier. Something like that. I guess they would have to be smaller, but I mean the area of the zone of tension, of connection, still exists. And especially you can see that when you put them in a vacuum or something and they reduce to a liquid. A liquid that doesn't have, that almost seems like a forced liquid. They're very flowing liquids. They're very little friction in them. But there's still continuity between them. It just seems like something almost magnetically held together, rather than like if there was two forces, like super glue and Elmer's glue, that they're held together with Elmer's glue, not super glue. As the diaphragm moves up, the air molecules striking it will get a little boost in speed. See, I think that's just bullshit. I'm sorry. Because that just would create heat. So a little boost in speed, I wave my hand, yeah, that's going to generate some heat in the air in here, but it's not going to do no sound creation. So I just don't buy that. And you're not going to, why doesn't heat move, 700 miles an hour through the air? If all you need is to move some molecules. So very hot, if I have a very hot oven, the heat doesn't move 700 miles an hour. No, there's no heat wave moving 700 miles an hour from that stove. These slightly faster air molecules then strike the slower moving neighbors, transferring the extra momentum and so forth. Yeah, I just don't think that explains it, because that doesn't explain why there are other ways of moving atoms, molecules, that do not in any way create any wave function. It doesn't have any strength. It doesn't have any durability. It falls apart. It gets absorbed and produces infrared radiation. It does not produce a sound wave. The speed at which this disturbance travels through the air will clearly, see, I love that, be comparable to the average speed of the molecules, but that doesn't mean that the diaphragm has to be moving anywhere near that speed. Well, says you. Like I said, I'm just saying it can move at that speed, and I believe it does move at that speed. And I believe it's silly to talk about frequency as a measure of, in my opinion, as a measure of how fast an amplitude is created. So I said this before, but the real point here is it's almost like a heart monitor, right? A heart monitor does this blippy thing, and then nothing, and then a blippy thing, and then nothing, and then a blippy thing, and then nothing. And what I'm arguing is this speed, okay, can be very fast and can be consistent for very different frequencies. You can have a much quicker frequency, and this speed of this amplitude would be identical in both these cases, and the only thing different is how many of these initiations there are. So I'm talking about the speed of the amplitude. You're not telling me how fast the speaker moves as it's creating this amplitude. Does it start off slow and get faster and faster and faster, or does it start off fast and get slower and slower and slower? I'm saying it's a very fast, and that's the speed of sound that's broken right there, and that it's the initiation, it's the creation of the amplitude, the speed at which the peak amplitude is created, that is the relevant component, not frequency. Alright. But that doesn't mean has to be moving. Conversely, when the diaphragm moves down, the air molecule striking it will lose some momentum. Yeah, well, this moving up and down thing is, again, a little bit tricky, because most of the movement, half the movement, is reflexive in terms of elastic movement. The speaker initiates a pull, and it lets it vibrate back. It lets it through elasticity flex back. So it's like flicking my nails, and it does make a sound, doesn't it? And why is it making a sound? Well, that's right, because the tip of my nail is moving quicker than the speed of sound, thus slowing it down a bit. Their faster moving neighbors will then lose some of their momentum, and so on. So he's just talking about the backward and forward motion, and the which is not explaining either, without explaining how these molecules are bound. There's one thing to explain how, when you're compressing them, why they move over. So when I force more people in the room, so when I compress something, you can sort of, that explains why people fly out the door. But why, when I pull, would that force anybody in the other doors? If these atoms aren't closely associated and connected through some sort of force, when I pull some out, when I make more room for them, why is that forcing the rest to move at just the same speed as when I compress them? So you'd have to explain to me why the speed is the same whether I'm expanding or whether I'm contracting the space in which the atoms exist in. And theoretically, that's sort of what a speaker's doing. It's expanding the space and then compressing the space. So why would expanding the space oblige the other atoms to move unless they're intimately connected through some force that you're manipulating when you're transmitting a wave of sound? And again, a wave of sound, I think, is going to turn out to be much like the particle-wave duality that exists with the movement of the electromagnetic spectrum, the photons. People think of it as this wave, but it's not really a wave. It's of indiscrete. It's a wave of discrete vibrations, individual vibrations, individual pokes in the environment. And there's just a huge amount of them, and that's why it can create a wave, is because there's a huge number of atoms being poked. And so it has the illusion of being one thing, but it's not. It's a bunch of little things again. Alright, notice that nowhere in this analysis is the concept of tension involved. Well, that's why, yeah, and where did you get this analysis from? I think it's completely bogus. Without explaining the tension, without explaining the fact that the atoms are associated, and they are associated in some intimate way, I don't think you're going to explain why heat doesn't travel as fast as the speed of sound. Just the collisions of freely moving air molecules and the transfer of momentum. In fact, gases can't be in tension, if by tension you mean the restoring force a material exerts when it is stretched. No, I don't really mean, saying stretched is another way of saying uncompressed, isn't it? Right? So I'm not arguing that when you fully uncompress some gases, you won't lose even the ability to transfer much sound. Right? I mean, theoretically, they're always compressed in any kind of natural state. They don't really gas molecules don't tend to like each other much. That's why they don't form into some kind of heavier molecule and fall to the ground. That's why they stay free floating. It's because they stay essentially atomic and singularly elemental. I mean, if they became big things, they end up being things called dust, and they crash to the ground. It gets sucked up by gravity. Well, anyway, if by tension you mean restoring force a material exerts when it is stretched, since gases can be expanded with no effort. Well, again, you say no effort. I think obviously there is efforts involved, and the fact that they are, unlike a liquid like water or something, the fact that they can be stretched and compressed doesn't say anything about the forces that are connecting them. The electricity between them can still exist at distance. So, like magnets, there's a field, and you can have the weaker field or a stronger field, but the field will exist for quite a distance. So you can have quite a variety of distance between two magnets, and the force will still be tying them together. You'll still have the attractive or the repulsive, whatever way you're going. But let's say the attractive force, you can move them closer and closer and closer, and it gets stronger and stronger, but it's still the force that connects them to each other is there. They will continue to function. If I tie them together in some mechanism, I can have them a ½ inch apart or a ¼ inch apart, and they will behave in symmetry with each other as if directly connected, even though I have separated them by twice as much distance. So how much distance you create between, say, hydrogen atoms in a gas doesn't necessarily change how much those gas molecules are communicating with each other magnetically or electrically or statically or however we should describe it. Also, your math is wrong. If a 10 kilohertz diaphragm travels at 44 miles, then a 40 kilohertz will travel at 176. Yeah, I made a mistake. My point was that it doesn't really matter, but I'm just saying fine, it doesn't matter. And I'm not just talking about audible sound, right? I'm talking about any sound transmitted through the atmosphere still moves at this 761 miles per hour. So let's not argue about what frequency it's at. I'm just saying theoretically, speed is not changed by frequency in these circumstances, at least not in any major way. I mean, I think in the noble gases or in something you can fiddle with frequency and change the speed subtly. But again, that'll probably have something to do with the dynamic of the atoms themselves. How the atoms are configured will change how this mechanism of getting to their core, their center of gravity, or however you want to describe it, is going to be affected. So that's not really the point. But my point is that it doesn't matter. 10 kilohertz, 70 kilohertz, 100, 1,000 kilohertz, 3 megahertz. It doesn't matter what the frequency is. The speed is going to be the same. And so we're just talking about how fast the vibration moves through the surface, the substance. So we're just talking about the speed of the medium. It doesn't matter what the speed of the initiation of the amplitude is. Again, it just depends on the quickness of the creation of the amplitude. All right. The speed of is well above both 176 and 440. Well, again, for the purposes of the argument, just make it 1,000 kilohertz and do this math, and then you're over the speed of sound. And obviously, the signal isn't going to travel faster than the speed of sound. So I'm just saying this is a bogus way to do the math for figuring out how fast something's moving. This does not tell you how fast the speaker diaphragm is moving. So it doesn't have anything to do with my argument. I'm arguing that the diaphragm of the speaker or some component of the speaker is in fact moving faster than 761 miles per hour. I'm saying some piece of that speaker is moving faster than that speed, regardless of frequency. The audible range of the human tops out at 20. Again, I don't care about audible sound. So a 40 kilohertz sound wouldn't even be audible. Well, who cares? Again, we're not talking about whether people can hear it or not. Okay, we're talking about sound that's propagated through atmospheres. So what would prevent the diaphragm from vibrating at some ridiculously high frequency? Its tensile limit. Yeah, and of course, but that again depends on how much amplitude you're pushing it at. Okay. So you're arguing that if you vibrate the diaphragm at a certain speed, well, here, I'll just finish this comment. As the diaphragm vibrates more and more rapidly with the same amplitude, there you go, same amplitude. Why don't you just reduce the amplitude? The tension in the diaphragm increases until the diaphragm simply breaks. Well, I'm going to argue that the real limit, okay, is a limit of how much frequency you can pump into something. Depends on how much, where it stops to have that elastic rebound. So like any string has a limitation to how many plucks. It won't come back in time for you to pluck it again, would be the argument. So the limitation of the speaker is the limitation of the speed at which the speaker can rebound. So if the speaker doesn't rebound before, so say I pull the speaker down and it rebounds. If its rebound speed isn't quick enough, that's the limiting factor to how much frequency I can pump out of that speaker. The speaker will do nothing once I exceed its rebound speed. That's what, you don't have to break the speaker. It's not going to necessarily break the speaker. It's just going to, the speaker's just going to say, F you. Okay, I can't do it this quickly. And it's just going to end up staying in the down position. It's not even going to go anywhere. It's just going to stay down because you're moving the frequency faster than it can respond as a material. Alright, hustle a day. Who I'm, pleased to see again, in a matter of speaking. It is interesting to observe, as you say, the tension involved in traveling general classic waves. Walter Lewin's lectures, I guess I have to look up that guy, explains this quite well as resulting from coupled oscillators, where a coupled oscillator is essentially a spring elastic weight assembly. Yeah, see, I just don't like this. I'm not saying it's fine. I'm just saying, see, the classic explanation is that sound is transmitted. Okay, spring, atom, and they're just making up this spring thing. Spring. Oh, okay, yeah, there's just springs. No. So I'm just saying, yeah, my idea is to say, I want to come up with the mechanical concept that is the spring. I want to explain the spring. I think the spring is more about, when the atoms are spinning, when an atom is got an electron flowing around it, what's happening is one half of the time the electron is in this side of the globe, and the other half it's in somewhere on this side of the globe, right? And so as that's happening, I think atoms next to each other are basically, when they start to get into harmony, they're flowing into each other on the negative cycle. So this one goes over here on this side, then this one's on this side at the same time, and they end up moving closer to each other. And then when they both come around the other cycle, they're both moving away from each other, or they're the opposite. They can be, this one can be in +1 position, this one can be in, X, let's say X position, this one's in Y position, vice versa. So you have your 4 permutations of positions that they could be in, blah, blah, blah. But that's accounting for the native vibration in all matter, is essentially the vibration being created by those orbits, and how they're all bouncing on those orbits. They're all bouncing on the orbits of the atom. Something like that. Weight assembly. The so-called wave-particle differential wave equation then pops out of the mathematical analysis of Newton's laws as applied to the system. But it should be noted, no such tension arrangement is necessary for electromagnetic waves, which is the puzzle, I guess. Yeah, well, yeah, that's sort of what I'm trying to get to, though, is that I think the tension does exist, in the nature of the universe, let's just say. There's a similar mechanics involved, I suppose. I'm getting to that argument, that the fact that these things seem to parallel certain aspects, like I said, even getting to the DNA model, the double helix arrangement, and the idea that double helix could be fundamental to the way some parts of physics are constructed. I think it's really interesting. If electrons were actually in a double helix, that would really be, oh yeah, now it starts to make sense that these patterns are repeated, and gives it a fractal kind of nature, that the core principle that magnetism is related to gravity and electricity, and that all these things are, we're seeing more difference than there is, and that at the core they are the same thing. Well, anyway, again, as mathematical analysis, only this time the Maxwell equations, which result in the popping out of a partial differential equation which describes a wave. Okay, this shit is deep. Yeah, well, see, that's some of these equations, what are they describing? They're not really describing what's happening. They're describing what the end relationship is, but they're not describing why the relationship exists. And so that's the big missing link thing. Popping out a partial differential equation. Okay, so this shit is deep. Maybe the mathematics of the analysis of fields. And yeah, again, see, I don't like the word fields. It just doesn't say anything. So I'm thinking that fields are really hooks. They're thin hooks of photons, or there's a mechanical thing that creates a field. A field is made of something. But anyway, emphasis, because I acknowledge their totally abstract nature, is equivalent to mechanical tension, but I don't know that to be true. I think I'll make a video. Well, that would be cool. Yeah, well, see, I'm thinking that there are hooks, that there are things tying things together, and that those hooks are broken, much like my burlap example of the atoms, and when they're shearing against each other, they're shooting off hooks of infrared light, that kind of idea. I'm currently listening to your part 1, but I will remark that the true development of your ideas only takes substance when you make them qualitative. That is mathematical rather than qualitative descriptions. Well, quantitative. Quantitative rather than qualitative. Well, whatever. It is a credit to you that you have the imagination to wrangle with both the practical and philosophical problems of physics. One of the major reasons that I went and studied math later in life is that I realized that the barrier to understanding the universe was the language that the theories are wrote in. Yes, exactly. I have a similar discomfort with this overemphasis. And I had a real problem with Feynman because of that, because he just kept arguing that don't think about it, just accept the math. Just accept this silly vector bullshit, like, oh yeah, I'm going to draw a line going this way and a line going that way, and then I'm going to draw the hypotenuse, and then I'm going to square it, and then I'm going to say that's, and yeah, okay, it works, but what are you describing? You're not that's not the way the world works. So, yes, you've paralleled the phenomenon with the math, but there's the phenomenon underneath. There's a reason why that math works, and let's get to the reason. Let's get to the... So we're back to, like, in my opinion, Einstein's variable thing. There's a missing variable here, and I think that's the answer. Unfortunately, it's a long haul. I didn't seem to soak it up quickly enough, perhaps, for I still find so many basics of higher math are still uncovered. Some of this math I'm totally avoiding. I'm just hoping, like, conceptually you can understand it, right? You can understand, without getting into a huge amount of the heavy part of the math, you can understand the idea that gravity decreases to infinity, the further away you go, or that, the same kind of phenomenon, where you can add up the gravity of, these 7 bottles can be here, and that the center of their gravity from an external source would be something, not any one of them would be the gravity. The gravity would be centered on some point, balancing all of their masses. So they're essentially a body that's going to be turned into a celestial body, in a sense, from my external perspective to them. And those kind of, you can understand them conceptually. You understand some of the reason why that math would work, but you don't have to know how to do the math to understand the general function of the math. So I'm just going to rely on that for now, and I'll get to the real math eventually. Alright, so this guy was really annoying. I found this totally disappointing, his response. So there's a guy who said the speaker doesn't move with the speed of sound, and he doesn't prove it or say anything. I don't know about this stupid Google Plus thing anyway. Says science, he says. Well, that's not an answer. Sound is quite well understood. Well, I'm saying it's not. I don't think it is quite well understood. I don't think they've explained any of it very well. I don't think they've explained what a sonic boom is, or sonic booms on the micro or nano scale at all. There is no reason to be ignorant about sound. I guess I'm not being ignorant. To just claim I'm being ignorant is being an asshole. So in my opinion, there's no reason to be an asshole. Okay, either prove speakers aren't moving the speed of sound, or use some other example where you can prove it. I can go on and on, repeat myself to make my argument, but that would be a waste of time. Well, again, you could go on and on making the same bogus argument that's a pile of crap. As I pointed out, you haven't refuted my argument that frequency has nothing to do with the speed that an amplitude is reached. Where have you counter-argued? You didn't. So fuck you with this attitude. Alright? It's just a shitty attitude. You're going to make a claim, then make it. I can explain to you how my larynx work, okay, and how there's pieces right on my larynx right now moving at the speed of sound. And that's why I have a voice. Shithead. I wouldn't call myself a naysayer, I would. I like you. I like you and most of what you have to say, Gary. I am a nitpicker, though. Well, again, you're not nitpicking with a fair argument. So now you got 3 likes on this bullshit response. Why don't you people write your names here? Why don't you post replies or say something saying I'm one of the assholes who thumbed up this nothing response? He didn't counter-argue here. Where's his counter-argument? Where is his proof? Here, go here, and I'll prove that speakers don't move faster than the speed of sound. That frequency is created slowly, and nothing ever moves faster than the speed of sound. Where's the proof of that? I don't see any proof here. Where did he prove that all amplitudes are reached at exactly the same initiation speed? That for every frequency ever created that we hear audibly, that frequency was created in some manner where it carefully did not exceed the speed of sound. Well, I'm arguing it's doing exactly the opposite every damn time. But anyway, yeah, I'm just saying he didn't counter anything I said. Alright, so this was a racer guy. Hey, in Mendham, have you watched the primer fields? I have tried like 3 different times to get through it. It's just some sort of religious crap, right? I mean, you know, they're trying to find domes and everything and trying to connect like it's the pyramid theories or something. It's just really fucked up. It's well produced, but it's really annoying. And they call things they shouldn't be calling things. I mean, you create some static electricity, you don't call it a plasma. That's kind of bogus. It's a very long video and slowly paced. You're damn right. But it's interesting. Well, I didn't find it too interesting. It's about the geometry of magnetic fields. Well, it's sort of about that, but not really about that. And the effects on plasma. See, it's not really a plasma. I like the explanation they gave for the 2-slit experiment. Yeah, well, I didn't get to that, but I really don't even know if I want to get to that, because it's probably going to bug the fuck out of me. And also the way they can link their theory to cosmology due to the scalable nature of plasma. I'd like to hear your take on the ideas. Well, I don't like the idea that they're explaining it by implying that somehow domes exist because it has something to do with plasma creation in a static electricity field or something. That's just plain stupid. I mean, the fact that there's some geometry involved in creating eccentric electrical discharges, well, duh. Yeah, I mean, duh. Let's see, how can I put that? Duh. Yeah, I mean, electricity is weird, right? You know, because electricity is this thing where, you know, if there's any kind of defect, any kind of aberration or peninsula on an object, all the electricity will tend to want to go through that little nub. So electricity tends to force things to be smoothed out, just because it hates anything dimpling its circle, its smooth surface. So yeah, electricity is not like a non-smooth surface. So yeah, it's going to tend to create something. It's going to tend to require perfect surfaces. So, but yeah, I guess I'll get to it. I just, you know, it is slow. So yeah, I don't know. I don't know what to say. I mean, I want to get to it, but I really don't want to watch it because it looks religious, and it looks. And again, it's just fuzzy. It's all this plasma blob. Plasma. What's a plasma blob? Come on. It's just too inspecific. I wish somebody else would watch it and critique it properly, and you know, within 20 minutes, just let me know why it's all a crock of shit, so I won't have to bother proving it's a crock of shit. Because I have other shit to prove crocky. So anyway, I think that's it. Thank you, Machine Ghost Guy, for pointing out that it's this Google Plus shit that means I can't respond to that snarky guy. Anyway, I think that covers it. Sorry, longer video I thought it would be. But this stuff is interesting, I think, and such.